Hello everyone, my name is Ayush Chauhan and today I am presenting my final year project on behalf of my team. My project ID is 2022CSEPID41 and the title is AI Calorie Counter for Indian Cuisine using segmentation and volumetric estimation. And we have done this project under the supervision of Mr. Manisha. So as we know that in today's era, proper food tracking plays a crucial role in maintaining good health and preventing chronic diseases. However, traditional methods of tracking diet, like logging or self reporting, are often unreliable. They depend heavily on user input, which can lead to an error or inconsistency. So, with the rise of the computer vision and deep learning, we now have the potential to automate this process. These technologies allows us to recognize food items and estimate their nutritional values directly from images, making the process faster and more user friendly. Despite these achievements, analyzing food from images is still a challenging problem. Food items come in wide variety of shapes, appearance, and presentations. In many cases, it's overlap or partially hidden, making inaccurate accurate detection difficult. So the problem arises is that when we are estimating food volume from a single RGB image, it becomes difficult due to irregular shapes and lack of depth data. And currently, dietary assessment solutions rely heavily on westernized data and fail to scale to culturally specific meals like Indian thalis. Means the Indian cuisine is the currently the applications we have are unable to detect the Indian cuisines as effectively. So the majority of approaches focus on classification accuracy rather than correct position, size, and exact food volume estimation. So our objective is basically to develop an AI-powered calorie estimation framework, especially designed for the complexity of culturally diverse mixed Indian cuisine. So to overcome the challenge of overlapping food items by utilizing deep learning based instance segmentation to accurate separate single meal presentation into individual dishes. To successfully calculate a calorie value by mapping these estimated volumes directly to established Indian nutritional standards and databases. So the previously available approaches are as multi-labeled classification plus menu prior to predict food items and link to neural tables and large benchmark data sets, instance segmentation, single view segmentation, which we can say can fail on a certain instinct. As we talk about the multi-level classification, it heavily depends on restaurant or menu information. It can't handle the homemade cooked food. And if we move towards the instance segmentation, it requires large annotated data, so which is not specifically trained for foods. We can say it more requires the fine tuning, so which becomes the difficulty. And another, if we talk about the shapes prior plus multi views reconstruction, so it basically works on the two approaches, single view approach and multi view approach. If we see about the single view approach, it relies on unrealistic shape assumptions, and if we talk about the multi view approach, it requires multiple images from different angles, which are not practically for everyday users. So this is the, we can say, a loophole for detecting the calories in our food. So basically our proposed solution is a four phase pipeline which we are using, in which firstly we are using ULO. Hence ULO stands for you only look once. So it is an object detection model, which is our first layer. So we use ULO to localize multiple food items in an image. Let's say we have a plate of thali. We have a thali and have multiple dishes in it. So our ULO is basically used to detect those particular dishes in that plate. And our second layer is for food category recognition, which is basically a clip layer. Clip generally stands for constructive language image training. So we, as the our detected the food, but it can't tell us which food is this. Like it detect a vegetable image, but it can't tell us the which vegetable is this. So we use clip for detecting that food item. And for portion and quantity estimation, we are calculating it by the estimate the amount of food based on size of detective region and simple assumptions. So if we talk about the workflow diagram of our application, so basically when the user provides the input, it goes through the front end to our back end. So our back end is basically made, we used Node.js for our back end, React for our front end, and for our Python microservice we are using ULO and Clip in our Python microservice, which is an another layer which comes as the user uploads the image to the front end. It goes to the Python layer. The we can say our backend redirect this request to the Python layer, which first uses the ULO to detect and localize the multiple food items as you can see in the image. And after that, using clip, we identify which item is that. Means is it a rice or it is a roti, and what is this. So after that we have to calculate the portion, which portion we are means what is the proportion of that particular item. So it is the third step which we have calculated, and after that we have calculated the nutritional mapping, and that JSON response of all these computed layer is sent to our backend and through backend to our front end, and we have shown that to our UI. So same, the flow chart is also the same. As the input goes, it goes to the ULO which detect the food items, and after that it goes to the clip which detects which means what is the name of that items. And after that we have calculated the proportion estimation and nutritional mapping, and then showcase the output. So let's move to the ID for better understanding of the project. Here we have three folders. Basically the client denotes our front end, and this Python backend is our microservice of Python, and this server is our Node.js backend. So when the request is sent from the front end, it first goes to the backend, our Node.js backend. Then that backend sends a request to the this Python microservice, and this Python microservice runs our ULO and CLI and calculates all the necessary details, and after that it sends the response to the server, and through server we have shown that response to the client. So and in this we can say Python microservice we are using ULO VX segmentation, means the ULO V8X model. So this model is basically very essential for we can say detecting the articles with high accuracy. And if we there are other varieties of art, these model, like ULO V8M, ULO V89, but the best of them is ULO V8X, which have it we can say 68.2 million parameters. So let's run all these services and see what are how our UI's project is working. So firstly we have started our Python microservice, and then our Node.js backend, and then the class. So this is the landing page of our application. So if a new user comes in, let's log in with a new user. So we can say demo account, dummy @ gmail.com, test@123. We have created our account, and let's select the age, the height, and the weight. Now we are logging with this grids. So when a new user enters, he will see the dashboard like this, and we have added many more features in our application rather than our scanning one. So user can also track their daily meals, how many energy, protein, fat, and carbs they have taken through that meal. You can also take the custom range of that, like 23, and it will update according to the that data. So after that you can also calculate how you have exercised, and if we can say how intake you have done and how you have burned the calories. So if you have done running for 30 minutes, you have burned 343 kilocalories. So if we done this and go to the graph, like intake versus burn, it will show us the calorie intake and calorie burn. Now we comes to our uh, main feature, which is the upload photo scanning section. You can also use it on the phone as we can say web app. So when you are using phone, you can take a photo at a real time and then scan it. Currently we'll upload the photo and see what is the result of this. So we can also check the logs. What are the logs saying? So in this Indian thali, we have identified a curry, biryani, tomato dal, red chili chutney, which is here, Spanish curry, paneer butter masala, which is here, and all the majorly it has detected all the cuisines or items present in this, and we can also check these in the logs and their respective scores. These are this.